Hello, 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 and welcome back to Shiksha DaCosta. Today we're going to be looking at quadratics in factored form. This is part of our unit on connecting the graphs and equations of quadratic relations. So today we're going to learn about a new form of representing quadratics, and it looks like this: y equals a times x minus r times x minus s. And you're successful at these skills about, the representing quadratics in this form when you can determine and describe the connection between the factors of a quadratic. Remember, factors are things that are being multiplied. Like here I see 1, 2, 3 things being multiplied. So the factors of this quadratic and the x-intercepts of the graph of that quadratic. To start us off, I want you to think about this. Suppose that you have two numbers that when you multiply them, you get 0. So a and b, such that a times b equals 0. Can you come up with some examples for a and b? So one of them is obviously a could be any number, and b has to be 0 if that's true. Okay, because any number times 0 must equal 0. What about if b is non-zero? Well, if b was not 0, then a would have to be 0. Whatever it is, one of them has to be 0 to equal 0, right? Can you come up with a pair of numbers that doesn't actually include 0, where neither of them is 0? No. Any non-zero number times another non-zero number will always be a non-zero number. If a is 0, could you find a value for b such that the two of them do not equal 0? If this was 0, can you come up with a number of b in a way that the end result will not be 0? No. Right? Any number times 0, we already know, always equals 0. And so this is sort of the basis for not only graphing quadratics from factored form, but also the basis for solving quadratic equations. So today we're going to learn about the most useful form of a quadratic, well, most useful in my opinion, factored form. Okay, the factored form for quadratic is a times x minus r times x minus s, and its name comes from the fact that it has three factors, right? A times x minus r times x minus s. These two, even though they are expressions that have like subtraction in them, they are still factors in that they are all being multiplied together. And just like we saw in our previous slide, if even one of these ever equals 0, the product of all of them will also be 0. It doesn't matter what the other ones are. So let's imagine this quadratic relation. Okay, y equals 3 times x minus 2 times x plus 5. What are some values of x that could make this equal 0? So these are our three factors. This factor obviously cannot be changed. So we won't even affect that. We were only looking for things we can do with x. So this one always is our a value, and our a value is not changeable. Okay, when we're looking for the roots of a quadratic, we're always looking for what values of x make this equal 0. This one right here, well, if x is 2, then this would be 2 minus 2, which is 0. And for this one right here, if x equals negative 5, then this would be negative 5 plus 5 equals 0. So let's double check to make sure that this is true. So when we plug in 2, this becomes 3 times 0 times 7. Again, it doesn't matter what these are. We're still going to end up with 0. And when we check negative 5, 3 times negative 7 times 0. Again, it doesn't matter what these two are, because even though this is negative 21, anything times 0 will still get us our answer 0 here. So the takeaway here is that if you see a quadratic relation in factored form that looks like sort of like this, the x-intercepts, or other words for that, are the zeros or the roots, are the values r and s. Sometimes it's easy to see what r is. In this case, r is 2. X minus r, x minus 2. R has got to be 2. But sometimes it's a little bit harder, because you're seeing x plus 5 here. So some students think, oh yeah, 5 is the answer, but it's not. It's a value of x that makes this equal 0. So what would have happened here? How did we get to x plus 5? S must be negative 5 because x minus negative 5, when you're subtracting a negative, an easier way to express that is adding a positive. Okay, so that's one area that kids usually mess up. And that's exactly what I'm saying here. So note that this is x minus, not plus. So x plus 2 means that negative 2 is the 0. So a quadratic in factored form is given by y equals a times x minus r times x minus s. You can easily identify the zeros of a quadratic once it's in factored form. It's any value of x that makes this equal 0 or that makes this equal 0. The zeros in this case are and s. You can also create a quadratic relation in factored form if you know the zeros and you know one other point. And we'll do an example of this. Okay. All you have to do is substitute the zeros that you know into r and s, the point into x and y, and then you just solve for the only one that you don't know, right? A. And that will give you the full quadratic relation. So here's a good example of that. Find the equation of this parabola. Well, we're going to start off with our basic factored form. We know that the zeros, just by looking at this graph, are here. There's 1 at 10, there's 1 at 30. So r is 10, s is 30. We're going to just insert those here. We also know, we have two other points. We have the vertex, which is 20 and negative 10. And we have the y-intercept at 0 and 30. Think about which one you would prefer to use here. Yeah, we can use either point. And we just need to find the unknown value of a. I chose the vertex, but you could have easily have chosen this if you wanted to stick to, no negative numbers because you don't like it. But anyways, you'll see that we get to the same thing. 20 minus 10 is 10. 20 minus 30 is negative 10. 10 times negative 10 is negative 100. And divide both sides by negative 100, and we get 0.1. So what is the equation of the quadratic? Y equals 0.1 times x minus 10 times x minus 30. Our next example here, find the zeros of this quadratic. Now this one is a little harder because it's not exactly factored form. We know one of them is 5. Super easy, right? But this one is a little bit trickier. As long as we, however, go back to our, that original statement that I made, right? That if any of these equals 0, that will make the product equal 0. And that's really what we're looking for, a value of x that will make all of this equal 0. So this one, of course, can't be changed. This one is the easy one. If x equals 5, then this is 5 minus 5 is 0. But this one is the tough one. What value of x makes this equal 0? I'm not going to try to guess and check this. What I'm going to do is actually make it equal 0 and then just solve. I'm saying some value of x makes this equal 0. So I wrote it down as just equal 0. And I'm going to solve for x the same way I would solve any linear equation. Right? So that's this and that I'm solving. I'm going to subtract 1 from both sides. And then I'm going to divide by 2. And I find out that the value of x is negative 1 over 2. Is that true? Can I plug that in here? Can I test that out? Okay. So if I plug in negative 1 over 2 here, 2 times 1 over 2 is just 1. And a positive times a negative is a negative. So negative 1 plus 1 is going to be 0. So these are the values of x that will make this equal 0. It is 5 and negative 0.5. The last one, and this one will really help us to actually graph a quadratic, is this example here. Find the vertex of this quadratic, because all you need to graph a quadratic is like the 2 zeros and the vertex, to be honest, right? So the vertex is, like we have mentioned before, is the x coordinate is the same as the axis of symmetry. The axis of symmetry is that vertical line, x equals h, where h is the average of the x coordinates of any 2 points that have the same y coordinate. Now, this is a weird way to say, why don't you just say the average of the zeros? But this specifically is not just limited to zeros. If you have any 2 coordinates that have the same y value, you can average their x values to find the axis of symmetry. And if we know the axis of symmetry, that we already have the x coordinate of the vertex. The y coordinate of the vertex is super easy to find. All we have to do is plug in the x coordinate. Okay, so let's do that. Right away, looking at this, I know the zeros of this function are positive 8 and negative 2. That means that these two are points on the function. And if they are and they have the same y value, we can use them to find the axis of symmetry. 8 plus negative 2 is 6. 6 divided by 2 is 3, so the axis of symmetry is x equals 3. And when x equals 3, if I plug 3 into my equation here, I find a y value of negative 100. So the vertex is at 3 and negative 100. So if I wanted to sketch this out, and I'm going to do this in the corner because I forgot to give myself too much space. My zeros are 8 and negative 2, so I'm going to not give myself a whole lot of space on the left. So let's say that here is negative 2, and that's 2, 4, 6, 8. And let's go up by 50s. 50, 100, negative 50, and negative 100. I'm going to plot my 2 zeros. So my zeros are 8, 0. That's going to be right there. My other one is negative 2, 0. And so that's going to be right there. And my vertex is at 3 and negative 100. So that's going to be like right over here. And now all I have to do is sort of connect these with a smooth curve. And I'm done. If I want to, I can also, to help me out here is plot the y-intercept. And to do that, all I would have to do is plug in 0 into x. And then I can have another point to plug to plot here that will help my quadratic get a little bit more shape. But like, honestly, this is good enough. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.